Hello everyone, welcome to Chapter 2, Lesson 6. This is Brianne Pernick for Robert Morris University, Math 0900. In this lesson, we are going to work on interpreting inequality statements, graphing an inequality on a number line, translating English phrases into algebraic statements, and then lastly, we are going to solve and graph an inequality. We do have some vocabulary words that I need you to make sure that you know. We have inequalities, is less than, is greater than, solution, solution set, and graph. We will be going over those words during this lesson, so please make sure that you understand their meaning before the end of the lesson. It's very important that you are able to interpret inequality statements and that you can translate between written language to that mathematical statement. So if we're using words and we have 5 is less than 7, using an inequality symbol, that would translate into 5 is less than 7 with the symbol pointing to the 5. Conversely, if we have 9 is greater than 4, and we translate that into algebra, we would have 9 is greater than 4 with the symbol opening up to the 9 and pointing to the 4. I did put this little image of Pac-Man here because it's sometimes easy to help us remember which way the symbol is supposed to point if you think of the inequality symbol like Pac-Man. Pac-Man is always going to eat the larger number. So the opening is always going to face the larger number in your statements. So we have less than, this is the is less than symbol, and we have is greater than, and that's the is greater than symbol. So just remember as you're going through this that the larger or that the open end of the symbol is always going to face the larger number. The pointed end of the symbol is always going to face the smaller number. Let's take a look at a couple of examples here to make sure that we can use the less than and greater than symbol. Go ahead and pause the recording and fill the question mark in with the less than or greater than symbol that is appropriate. As soon as you're finished with A through D, go ahead and play the recording again and we will check your answers. Okay, at this point you should have had an opportunity to fill in the question mark with a less than or greater than symbol. For letter A, 3 is larger than -1, so you would have wanted to use the greater than symbol. 3 is greater than -1. Letter B, -2 is less than 1. Letter C, 0 is less than 3. Letter D, -3 is less than 0. So those are the symbols that you should have filled in there. That was just a quick review to refresh our memories on how to use the less than and greater than symbols. What we're going to start talking about now is graphing an inequality on a number line. When you introduce a variable into the inequality statement, such as x is greater than 3, what this means is that x could have the value of any number that is larger than 3. any number in the world. So it could be 3.1, 3.2, 3.3, 4, 5, 6, 7, all the way to infinity. 3.01, 3.0001. Any number that's larger than 3. As long as it's bigger than the number 3, it could be the value of x. Okay? So any number that makes an inequality true is called a solution of that inequality. So 4 is a solution. 5 is a solution. 3.1 is a solution. Any number that would make that inequality true is a solution. If we look at the set of all numbers that would make that true, we then call it the solution set. So the solution set would be any number that's larger than 3 all the way to positive infinity. We often graph the solution and the solution set for inequalities because sometimes it's easier to see them and visualize them than it is to think about them abstractly. So let's make sure that we can graph. Letter A says graph x is greater than 3 on the number line below. So the first thing that we want to do is locate 3 on our number line. And what we're going to do here is put an open circle on that number line. And the reason that we use an open circle is because we want to indicate that 3 is our boundary number and that it's not included in our solution set. So an open circle tells us those two things, that it's the boundary and that the number 3 is not included in that solution set. So then, after you put your open circle on the number line, you refer back to your statement and you say 3 is greater than, x is greater than 3. So where are the numbers greater than 3? Is it on the left of 3 or is it on the right of 3? It should be clear that the numbers to the right of 3 are greater than them. So you would shade that graph to the right of your open circle so that you can see that we're looking for the numbers that are greater than 3. Let's try letter B. Can you please go ahead and try this one on your own? We want to graph x is less than 2 on that number line. X is less than 2. Pause the recording. Graph this inequality. When you're ready, we'll check the numbers together. By this point, you should have had an opportunity to graph it. Now keep in mind that you are using the number 2 as the boundary here. So we would want to put an open circle on 2. And the statement says that x should be less than 2. So where are the numbers smaller than or less than 2? To the left of our open circle or to the right of our open circle? It's to the left. So we're going to shade all of the numbers that are to the left of our open circle. And that's all we have to do for the graphing of our inequalities. We're going to put an open circle and we're either shading to the right if it's greater than or to the left if it's less than. What we're going to look at now is the introduction of is less than or equal to or is greater than equal to. Sometimes we will need a value that is not necessarily greater than or smaller than, but it can also be equal to our boundary number. So we need an algebraic or mathematical symbol that will tell us that it's also equal to, or that it can be greater than or less than. So in a situation like this, where it can be equal to or larger than or smaller than, we use the is less than equal to symbol, or the is greater than equal to symbol. When you see these symbols, that tells you that you can include your boundary number in your solution set. Now, these problems can be graphed as well, but there is a difference in how we graph them. We have to use what's called a closed circle to show that the graphed number can be included in the solution. So it is the boundary, and it's also part of our solution set, and that's where the equal to portion comes in. The closed circle represents the equal to. So this time we're going to graph x is greater than or equal to 3 on the number line below. So you find your number boundary, which is 3. We put a closed circle, and then we want the numbers that are greater than that. So we're going to shade it to the right. Go ahead and try letter D. We want x is less than equal to -2. Pause the recording, graph this inequality, and when you're ready, we'll check your answers together. Okay, at this point you should have graphed letter D and you should be ready to check your answer. Your boundary number here is -2, and since we're using a less than equal, we want to use a closed circle so that we know that -2 can be included in the solution set. And since x is less than or equal to, we would shade to the left so that we know that the values are less than. At this point, we're going to move on to our next objective, which is translating English phrases into algebraic statements. It's very important that we are able to translate from English phrases into algebraic inequalities. For example, we need to be able to translate the following statement into an algebraic statement. The police on the scene said that the car was traveling more than 80 miles per hour. Use the variable s for speed. How would we use an inequality to represent this real-life situation? We know that we're using the variable s, and we know that the police car was going more than 80 miles an hour. More than would translate into is greater than, because that car's speed is greater than 80 miles per hour. S is greater than 80. Letter B. The owner of the trucking company said that the payload of a truck must never exceed 4,500 pounds. Use the variable P for payload. Pause the recording, write an expression that can represent this situation with an inequality. Okay, by now you should have written your expression. Now your key words here is that it must never exceed. So since it cannot exceed 4,500 pounds, that means that it cannot be larger than 4,500 pounds. So it can be smaller and it can be equal to, but it can never go over. So P is less than equal to 4,500. Last one. Only people who are more than 4 feet tall may ride the roller coaster. Use H for height. Go ahead, pause the recording and write this inequality. Okay, by now you should have had an opportunity to write the expression. To ride this roller coaster, you have to be more than 4 feet tall. It does not tell us that if you're 4 feet tall, you can ride the roller coaster. It says that you have to be taller. So that tells us that H must be greater than 4. Okay, our next objective for this section is for us to be able to solve and graph inequalities. The inequalities that we're given will not always be a simple statement such as x is greater than 3 or h is greater than 4 or s is less than 80. You will have to solve inequalities in a very similar fashion to how we solve equations. Solving requires us to perform all of the steps possible to get to the point where we see all of the possible values for that variable. And what that means is that we're getting down to the inequality where the variable is isolated and the numbers are on the other side. Now, there is only 2 differences with how we will solve inequalities. Everything that I taught you so far about equation solving will remain the same. The only difference is that, and this is a big difference, is that the symbol, your inequality symbol, must be reversed when you multiply or divide by a negative number. And here's some examples why. If we have -2 is less than -1, that's a true statement. -2 is less than -1. However, if I multiply both sides by -3, let's see what happens here. Negative times a negative makes a +6. A negative times a negative makes a 3. If I leave my symbol the same, that is no longer a true inequality because 6 is not less than 3. 6 is greater than 3. So we must reverse the inequality because a negative reverses the operation. Another example is that if we have 8 is greater than equal to 4, and I divide both sides by -4, let's watch what happens. 8 divided by -4 is -2. 4 divided by -4 is -1. Our original symbol was greater than equal to. If I leave that symbol in there, this is no longer a true statement. I must reverse my inequality in order for it to be a true statement. So let's work through some examples here. Let's just make sure that we can solve these inequalities and graph them. We have 3x plus 7 is greater than equal to 13. You will approach this problem exactly the same way that you approach equation solving. We want to start by undoing our addition. So we will subtract 7 from both sides. So we have 3x is greater than equal to 6. We will divide both sides by 2. X is greater than equal to 3. Graphing it, we want to put a closed circle on our boundary because it was greater than equal to. And we want all of the values that are greater, so we shade to the right. I would like for you to solve letter B. Please remember the rule about what happens when you multiply or divide by a negative number. Please pause the recording, solve the inequality, and when you're ready, we can move forward. Okay, at this point, everyone should have had an opportunity to solve letter B, and we should be ready to check our work. We're going to approach this exactly the same way that we do with equation solving. So the first thing I want to do is move my positive 5. So to undo a addition, we will use subtraction. So we will subtract 5 from both sides. That leaves us with negative 3x is greater than 2. Next, I want to undo the multiplication of negative 3. So I will divide both sides by negative 3. When you divide by a negative, you must reverse your inequality, and that leaves us with negative 2/3. So our answer is that x is less than negative 2/3. So I'm going to put an open circle where 2/3 would lie. And then I want to shade in the less than area, so that's to the left. One last example. And it is a fractional example. So this will require us to clear our fractions and then solve the inequality. Please go ahead and solve letter C. As soon as you're ready, play the recording and we will check our work together. Okay, by now you should have had an opportunity to solve letter C. The first thing that we want to do is identify the LCD for our fractions. The LCD is the smallest number that every denominator will divide into, and it happens to be 8. So I am going to multiply my entire inequality by 8. So I want to think to myself, 8 divided by 2 is 4. 8 divided by 2 is 4. 4 times negative 13 gives me negative 52x. Bring down my less than equal symbol. 8 divided by 2 is 4. 4 times x is 4x. 8 divided by 8 is 1. 1 times negative 15 is negative 15. At this time, you now have eliminated your fractions and you have an inequality that has variables on both sides of the inequality. We have to move one of the variables to the other side. Since the negative 52 is already more isolated because there are no terms with it, we should move the positive 4x. So to move a positive, we will use subtraction. So we will subtract 4x from both sides. When your signs are the same, you keep the signs and add the numbers. So we have negative 56x is less than equal to negative 15. Lastly, we want to undo multiplication by dividing both sides by negative 56. When you divide by a negative, you must reverse your inequality. A negative divided by a negative makes a positive, and we have 15 over 56. Now, since we are graphing, it is sometimes easier to graph whenever a number is in decimal form. So I converted this to a decimal. 15 divided by 56 is approximately 0.27, which is about a quarter. So I'm going to go a quarter of the way and put a closed circle on my graph. And I want any value that is greater than 0.27. So I'm going to shade to the right. That is the last example that I have for you from this section. If you have any questions about anything that we did, please feel free to contact me and I will be more than happy to go over anything with you or do live tutoring or answer any of your questions. Thank you and have a great day.